Hello, welcome to my YouTube lesson series, The Concepts of ICT. In this lesson, I am going to discuss about the second lesson of grade 11 lesson series, the System Development Life Cycle. It can be called as an extension on the first lesson as well, because the first lesson was basically on development of software or developing programs. So in this lesson, we are going to discuss about the system development lifecycle, or the way we develop a software or a system. So as you can see, these are the objectives of this lesson. At the end of this lesson, you should be able to define what is a system and the interactions among components in a system, manual information systems versus computer-based information systems, then the ability to determine why a system is necessary, steps in the development process of an information system, the use of lifecycle models to develop information systems. So those are the objectives that we are going to cover in this lesson. First, we are going to discuss what is a system. We have come across this concept in grade 10 as well. In the first lesson itself, I think we discussed what is a system, and even you have discussed about this system concept in your science lessons as well. So what is a system? Simply, we define a system as a set of components that work together in achieving a common goal. That is what we call a system. So it is a set of components that work together. They should be working together, or we can simply say interact, in achieving a common goal. So these parts should be there in this definition. A set of components, it should be a set of components, and they should be working together, or they should be interacting, and they should be working together in order to achieve a common goal. That is how we define a system: a set of components that work together in achieving a common goal. Hope you understood. If you go through a set of systems that we have come across, we can discuss about this definition through an example. For example, let's take the system, school system. Yes, that is the best one that we can define this definition. So school, when we take the school, what are the components that we can find? And before going into the components, let's see what are the goals or the objectives of the school system. The goal is producing a citizen who is responsible, who is worthwhile, who is good to the society. So in achieving that goal, what are the components used? There can be teachers and non-academic staff as well. Then there are buildings. The canteen even can be called as a component. The playground, the library, the labs, computer labs, whatever the science labs, all those are the components that work together in achieving that goal we discussed before, producing a worthwhile, responsible citizen to the society. So we need all those components working together in achieving that goal. If we take another example, let's take a bicycle. What are the main components, or what is the objective of this device, of this system? Let's say simply transportation, go from one place to another. So what are the components? There are wheels or tires, then there are pedals, a handle, brakes, all these components should work together if we need to go from a place to another. If they do not work interactively, we might not be able to achieve that goal. So that is how the components of a system interacts. Okay, hope you understood the concept of this system. And again, as we have already discussed in grade 10 as well, there are main three components of a system. We call them the input, process and output. So this is how they work. You input data or whatever the thing, and by a particular process, it generates the output. This is how these three components work. You input something, and using a particular process, it generates the output, intended output. So that also can be called as the main components of the system. A system, whatever the system we take, there are inputs, a process and an output. Even the school system, we know that the inputs are the students. The process is giving education, giving opportunities to work in groups, and even for extracurricular activities, co-curricular and extracurricular activities, to create the responsible, worthwhile citizen. Just citizen, it says just as well, just citizens to the society. So as we discussed, the children or the students are the input, and the process is that giving the education, extracurricular activities and opportunity to work in groups and even the sports, all those things, and at the end provide a good citizen to the society. So that is how we define the inputs, process and output of a system as well. So as we discussed up to now, a system is a set of components that work together in achieving a common goal. And when we take a system, there should be the main three components: input, process and output. Whatever the system that we take, there are these three components. Hope you understood what we have discussed up to now. Next, we'll move on to the concept called information systems. Information systems. What is an information system? Simply a system that converts data into information we call information systems. Through a particular process, it converts data into information. That is what we call an information system. So when we discuss about these information systems, there are main two types of information systems. We call them manual systems and automated systems. Manual information system can be whatever the thing where we gather data. It can be a file, it can be a cupboard simply where we keep whatever the records that we need in a particular place. If it is a school, the records of the students, the records of the teachers and all these stuff. So that place is called a manual information system, or simply a manual system. And on the other hand, an automated system, or we can call it as an electronic information system as well, because an automated information system is mainly based on a computer system. All the information or the records are gathered in a computer or a system. So if we compare these two systems, what is the better one? Is it the manual system or the electronic or the automated information system? If we take the manual information system, let's take a scenario that we need to find the records of a student. When he needs to get the leaving certificate, we need to get the records of that particular student. Let's say that we are using a manual system. So when he comes to the office or the education office, and he says his requirements to the person or the clerk who works in that particular place. The clerk has to go through all the cupboards and find the particular file. For that, he needs to go through the cupboards, if let's say, which are dedicated to each year of the students, and after finding that particular cupboard, he needs to go through all the files of the students to find this particular boys or girls file, and from that file he needs to find the records that he needs in order to create the leaving certificate. So this process might take around 10 to 15 minutes, might be, we don't know, depending on the way they have arranged the documents and the number of children studying in that particular institution. But if they are using an electronic system or an automated information system, what is the process? When the student asks for the leaving certificate or requests that particular certificate, the clerk just have to insert or input the admission number of that student or the name of that student. Then he will get all the records stored in that particular machine about the student. It will take just 2-3 seconds maybe. So the speed is there in an automated system, and also the space, the physical space it takes to store these details or the records of the students. If there are, let's say 3,000 students in that particular institution or that school, they might be needing around let's say, how many cupboards? I don't know, 6-7 cupboards maybe, to store the records of those students. So in this case, if they use an automated system, they just need a single computer to store all those details about the students of the school that are currently studying and that have already left the school, the old boys or the old girls. It is just simple as that. So if we compare these two systems, the automated system or the computer-based information system and the manual system, we can find these few facts. In computer-based information systems, the errors are minimal because the data are processed by the computer or using computer programs. As we are working in a manual system, as humans are working in manual systems, they can be making mistakes, simply more than a computer. So compared to the manual system, the errors are minimal in a computer-based information system. And it says that the data can be processed efficiently. The efficiency is higher than a manual system. And as we discussed, the physical storage space that needed to store all this data is smaller compared to a manual information system. There can be filing cabinets in manual information system which will need large space. And also it speaks about the security of these data. Because of the usage of backups and passwords, the loss of data is less than the manual information system. So those facts are there when we compare these two information systems, the computer-based information system or the automated information system and a manual system. Okay, hope you understood what we have discussed up to now. We discussed what is a system, then we discussed the main components of the system and how they interact, and again we discussed about the main three components: input, process and output. Then we came to this information systems, and there we discussed about two main information systems which are called manual information systems and automated or computer-based information systems. And we did a simple comparison between these two information systems. And now we come to the most important phase of this lesson. which we call the system development process or the system development life cycle, SDLC. So the system development life cycle consists of 6 main steps. So these are the steps that we use in system development. This is the structure, or this is the framework that we follow in developing a system or a software. So these are the main 6 steps that we are following in system development in software companies. The 6 steps are, the first one is the identification of requirements, then designing the solution, coding of the solution, testing and debugging, deployment of the system, and the last one, maintenance of the system. Now we will discuss about these steps in detail. When we are designing a system or when we are developing a system, the first and the most important phase of this development is the identification of requirements. That is, you have to identify what this system should do, the functionalities of this system, the requirements. There can be functional and non-functional requirements of this system. So these should be identified correctly if you need to develop the system correctly, or if you need to get the correct system at the end of development. So this is the most important phase of this SDLC, of system development life cycle. So this can be done, the identification of requirements, it can be done in many different ways. Simply, if you know the client, or if you know the person who needs this system, you can just go and interview him. You can just prepare a discussion with him, and you can just get his idea on this system and get his requirements of this system. So interviewing can be used in identifying the requirements of a system. Interviews. And again, if you do not get a chance to interview, and even if you have already interviewed the person, and at the moment if they are using a manual system, you can just go and observe what they are doing. Observe how they work, what are the steps they take, what are the functionalities they perform. Through the observation also, you can identify the requirements of the system that need to be developed. So now we have discussed 2 main methods that we can use to identify requirements of this system. We call them interviews and observation. And again, if they are using a manual system, if the client is using a manual system at the moment, you can just go and observe the documents they are using. You can go through the documents they maintain in order to decide what are the data that you should keep, you should store in the system, and how they are done. So we call that document sample collection. And again, if you know the users of this system that you are going to develop, you can just distribute a questionnaire and get their idea on the functionalities they need to have. Let's say that you are developing a social network, then you can just distribute among the teenagers or the children or whatever the target audience, and get their requirements and get their interests on the system. What would they like to have in the system? Things like that. So the questionnaires also can be used in identifying the requirements. Another method that we can use is prototyping. What is a prototype? It is not the actual product, but it is something like the product, or it is a blueprint of the thing that you are going to develop, or a sample of the system that you are going to develop. And you can just distribute it among the users and get their idea. So there are 5 main methods that we can use in getting the requirements of the system, they are mainly the interviews, observation, document sample collections, questionnaires, and prototypes. So those 5 methods can be used in obtaining or getting the requirements of the system. That is what we do in this step, the identification of requirements. And then we'll move on to the second phase, or this designing of the solution. After identifying the requirements, you have to design the system, how it should look like, what are the interfaces that you should use, what are the databases that you should use, what are the languages that you should use in developing this system. All these things you have to decide in this particular phase. What it should look like at the end. You make the design at this phase. So those are the simple things that we do in this designing of the solution. They have listed some works that is done in designing, identification of software and software architecture, and user interface that, as we have discussed, main hardware systems and the dependencies of the subsystems, designing of the required hardware and software to run the system, designing the infrastructure for software, databases, user interfaces, and planning the tests that I didn't discuss. Planning of the tests. After the next phase, which is coding of the solution, we have to do testings of the system. For the testings to perform, we have to have the set of test cases to perform in order to identify whether we have developed the correct system which is needed according to the functional requirements or the requirements we identified in the previous phase. So here we are designing the test cases as well. We check it for the functionalities, for the quality of the code, for the speed, whatever the thing. All test cases should be designed in this phase. So that is what we do in designing the solution. Then we'll move on to the next phase, which is coding of the solution. In the previous phase, we decided what are the languages that we are going to use in developing the system and what are the requirements. All those stuff will be coded in this phase. And simply remember, in software companies, there are teams working on projects. There are several teams, there can be several teams working on a single project. And the functionalities of this system are distributed among these developers or these teams. What a team has a particular functionality to develop, and the team leader will distribute that particular functionality or the set of functionalities among the members of that team to develop. We call them units. So simple units will be developed first by each member of the team. So that is how the development happens. So after the coding of the solution or development, we move on to the next phase, which is testing and debugging. What is debugging? Have you heard about this word, debugging? A bug is simply an error of the code, an error of the functionality of the code even. So in this phase, we are going to test the code for errors and we are going to correct them or debug them, testing and debugging. So as I explained in the previous phase, that the codes are developed in as units. So in testing also there are 4 phases. First, those units will be tested by the programmer himself. That is called the unit testing. After testing the units, if they are correct, if they have developed the code correctly, they will integrate the units. Simply say, let's say they integrate the units which are developed by the team members and they check whether they have achieved the functionality they are required to develop. If they also have correctly developed the system, Then all the teams will move on to system testing, where the codes of all the teams will be integrated and tested for the functionality of the whole system, whether they work together perfectly. That is what is done in system testing. The whole system is tested for its functionality. And the last phase of testing is acceptance testing, which is mainly performed by the client of the system. He comes and checks whether the development team has developed what he needs, what he required. That will determine the success of the system. Acceptance testing. So there are 4 phases in testing: unit testing, integration testing, system testing, and acceptance testing. Hope you understood the concept of testing and debugging. And after the testing phase, we'll move on to deployment. For deployment also, there are 4 methods that we can use. In deployment also, there are 4 methods that we can use in using this system in deployment simply. We call them direct deployment, parallel deployment, pilot deployment, and phased deployment. Direct deployment means if you are using a manual system at the moment, or another system, another electronic system at the moment, you're going to just terminate the use of that old system, and you are going to use the new system from there onwards. This is the old one and this is the new system. That is what we call the direct deployment. You just terminate the old system and you start using the new system from scratch. In parallel deployment, you use both systems parallelly for some time. You use the old system and new system parallelly. If the new system does not have any errors, if it gives you what you needed, then you'll start using that new system after some time based on the success of that new system. So that is what parallel deployment is about. Then pilot deployment. In pilot deployment, you use the new system only in some places. If the system is used for a company, only 2 or 3 people are going to use the new system until they say that the system is successful. The others will continue to use the old system. That is what pilot deployment is. Based on the success of the experience of the people who use the new system, the company will move on to that after some time. The whole company. Or if it is used by a company which has several branches, only a single branch will use the new system while all the others use the old system. Based on the experience of the people who use the new system, the others will also shift to the new system based on the success. So that is what pilot deployment is. In phased deployment, the system will be developed in phases. First, only a single functionality will be used from the new system, and if it is successful, they will move on to the next functionality of the new system, and it will not be used by the manual system or the old system. And after they find that functionality also is successful, they will move on to the next as well. So in the new system will be used as phases, incremental phases. At the end, the new system will be used for all the functionalities. So that is what phased deployment is about. So in deployment, we can use 4 different methods. Direct deployment, where we terminate the old system and we are going to use the new system, and parallel deployment, where we are going to use both new and old systems at the same time. Pilot deployment, where we are going to use the new system only in a single user or a few users, while all the others are using the old system. Based on the success of the new system, of the experience of the people who use the new system, all the others will move on to the new system. And in phased deployment, the functionalities will be implemented in the new system as phases. So that is how we deploy a system. And at the end, the next or the last phase of SDLC, system development lifecycle, is maintenance of the system. In this phase, we are going to solve the problems that arise when the system is deployed or used by the actual users. And also we are going to give them training that need to use the system in this phase. And also if they are going to need more requirements added to the system, those also will be added in this phase. And any updates on technology will be done in this phase. So that is what the SDLC about. So there are 6 phases of SDLC: gathering requirements, designing the solution, coding of the solution, testing and debugging, deployment, and at the end, maintenance of the system. Hope you understood what we discussed up to now. Next, we'll move on to system development lifecycle models, some other frameworks that gives the SDLC steps in different ways to be followed in system development. So these also are called some frameworks. They also can be followed in developing systems. Some main frameworks that we use are Waterfall model, iterative incremental model, prototyping, spiral. There are some more models as well. We are not going to discuss about all these development models in this lesson, because we are only going to discuss about these 2 models, waterfall model and iterative incremental model. So waterfall model, it is almost like a waterfall. It moves on. The waterfall cannot move backward. It always flows forward. So that is the same concept used in this waterfall model as well. All the steps in SDLC are used in waterfall model: identification of requirements, planning the solution or designing the solution, implementation of the solution or coding, testing and debugging, deployment, maintenance. And as you can see, the output of this first step will be the input for the second phase, and the output of the second phase will be the input for the third phase. It moves on like that, and it cannot move backwards. They cannot go from second phase to first phase because it is a waterfall. So if you move on to planning the solution or designing the solution, you cannot come back to identification of requirements. When you are in implementation of the solution, you cannot come back to identification of requirements. Simply as that. Waterfall model moves on. So if you are going to use the waterfall model in system development, you should identify the requirements correctly. Otherwise, the whole system will be a failure. Whole project will be a failure. So this model is not used for big projects where the requirements identification is a bit critical. So it is basically used for projects where the identification of requirements can be done easily. Otherwise, there's danger of failing the project. There can be a chance for failure. And also, the product of this system can be seen only in the final phase, only at the final stage. Until then, you cannot see what you are developing. So that also is a risk in this development model. So as a solution, the iterative development or iterative incremental model is introduced. In this, they are working in iterations. In each iteration, there are identification of requirements, planning, then analysis and design, implementation, testing, evolution, and deployment. And again, it moves on. Again, they try to identify the other requirements. Then for those requirements, they will plan and analyze and design, then implement, test, evolution, and deployment. It moves on. At each iteration, they will have a product. Then they can see whether they are developing the correct product. If they haven't, they can move on to the next iteration where they can identify the requirements again and they can develop the product for those requirements they have identified in that particular iteration. So the risk is less than the waterfall model. The risk of failure is less. So it can be used for big projects as well, not only for small projects. But waterfall model is easier to implement than this iterative incremental model. So the waterfall model is used for simple projects, and this iterative incremental model can be used for complex projects as well, because it evolves it in each iteration. It improves the functionality in each iteration. So that is it. That's the end of this lesson. So in this lesson we have discussed, first we discussed what is a system, and we try to define that using some examples like school system and the bicycle. Then we came across another concept or the main components of the system as input, process and output, and we discussed that all the systems have all those components. And then we came across this concept called information systems. There we compared the manual systems and computer-based information systems. And after that we discussed about the SDLC or system development lifecycle. There we discussed about the 6 main steps of the SDLC: the requirements analysis or identification of requirements, designing the solution, coding of the solution, testing and debugging, deployment and maintenance. And we discussed about each phase in detail, how we do each and what we do in each phase. Then we came across the models or the frameworks that uses SDLC in different ways. There we discussed about 2 frameworks: waterfall model and iterative incremental model. Hope you all understood what we discussed in this lesson. So that is what you need to know about this lesson. Now let's go back to the objectives that we had at the beginning of this lesson, and let's see whether we have achieved them. So we discussed what is a system. Yes, we discussed and we defined what is a system, and we discussed how they interact, the components, how they interact, and inputs, outputs and process, how they also work. Then we compared manual information system and computer-based information. Yes, we did that, and we know the comparison between them. And we did not exactly say this, but we know why we need a system, and we discussed that even at the beginning using some examples in defining what is a system. We discussed about the school system and the bicycle. And steps in development process of an information system or the SDLC. We know the steps and we know in detail what in each step is done. And at the end, the lifecycle models or the frameworks, we discussed what are they and how they work and the differences in them. Okay, that's it. That is what this lesson is about. Hope you all understood the concepts. Hope you all got the main points of this lesson. If you have any questions, you can use the comment section, and you can go through my previous lessons as well if you are interested in the concepts of ICT, of course. And don't forget to like and subscribe my channel. So see you again on the next lesson. Until then, bye.